So the time in seconds taken for the pendulum to complete one swing. That means the pendulum starts here, goes to the right, goes to the left, and comes back again to the starting position. And that's modeled by this equation. Time is AL to the B. The L is supposed to be in meters, is the length of the pendulum, and A and B are constants, because the pendulum may be various lengths, like this green one over here is shorter compared to the white one and compared to the red one or orange one right at the bottom over here. Now we are going to show that this relationship can be written in the form of what's inside this rectangle. So we need to change this form into a log form. To do that, we'll just put a log in front of it. And we do the same thing on the right hand side as well. And so to remind myself what it's going to look like, I've just put this equation down here below. All right, we've got the first part of it is fine. Now let's need to rearrange the right hand side. To help you with this, I want to draw your attention to these laws of logs. We're going to be using this one over here. When x multiplied by y, we can change it to x plus log y. The other law, which is log x to the power of k, we bring down the k in front, log x. So this is what we'll do to this part of that equation. And we're nearly there. We just need to rearrange the terms. And now we have the equation as required. So this is the graph that was shown above, and it shows, it's a figure 3, and it shows that there's a linear relationship between log 10t and log 10l. If there is a linear relationship, then we could identify the various terms, such as this must be log t must be y, and b must be the gradient, and log 10l will be the x value, and log 10a will be the intercept with the y axis. That's going to be c, which is log 10a, and log t is y, and log l is x. B is the gradient, which is m. And we need to use the information that the straight line passes through these points, and therefore we can complete that equation, but we need to then change it to t is equal to al to the b. We can find the slope m, which is going to be y2 minus y1 over x2 minus x1, and we can make x2 0.21 and y2 0.45. Similarly, x1 will be minus 0.7 and y1 will be 0. Using those values, we can substitute. And since this is a ratio and decimals are not nice, so I'll just move it to 45 over 91. Okay, now using the equation of the line, we might be able to find C. We can choose one coordinate, and I'll choose the one here at the bottom. So we will have y minus y1, which is 0, is equal to the slope, which is 45 over 91, multiplied by x, take away 0.7. And that ends up with y equals to 45 over 91 x plus this, so that becomes y is equal to 45 over 91 x, and this is going to be our value C here, which is 9 over 26. Now remember what we said, that y is really log 10t, and the slope is still the slope, 4591. What is the x? X is log 10L, and log 10A is 9 over 26. So remember, we need to find it, the t is equal to AL to the b, which means that we're going to use the laws of the logs, but in the opposite direction of what we did before. So we rearrange this equation above, and we'll say that that's log t, and we'll move the log L to the left hand side, which will be 45 over 91 log 10 to the L, and we'll leave the right hand side 9 on 26. So once again, using the law of the logs, I am going to rewrite this, leave the log 10t, but using one of those rules, this time the exponent one, we will have, and we'll put that 45 to the 91, and that's equal to 9 on 26. Now 2 logs, if you take them away, can be rewritten as log 10 t over L to the 45 over 91, and that's equal to 9 over 26. Now, how do I get rid of the log? I will do the opposite, and I will put it both sides to the power of 10. So that means that now t over L 45 over 91 is equal to 10 to the power of 9 over 26. And that means that t is equal to 10, 9, 26 times L 45 over 91. So this is our A value, and this is our B value. So T therefore is equal to, if we use the calculator, we'll find that that is 2.22, and L to the 0.495, and that was to 3 significant figures. In our last question, we want to know, with reference to the model, interpret the value of the constant A. The constant A is 2.22. That constant 2.22 is only 2.22 when L is equal to 1. So if L is equal to 1 meter, then 1 to the 0.495 is still 1. and therefore t is equal to 2.22. So what we want to say is that the time taken for one swing when the pendulum is 1 meter. I hope that was a valuable explanation, and if you found it valuable, then please subscribe so that my videos can go far and wide, and you'll be able to get notification when I make more videos. And also make sure that you tick the like. And if you'd like to have a look at my channel, you might find that there are other videos of interest to you. There are a number of playlists that you could look at that will all be helpful for year 12 and advanced A level.